In this video, I will discuss derivative of a sum, a product, and a quotient. Derivatives of the sum. Considering the equation y is equals to x, to determine the formula of the derivatives of the sum, assume x is equals to the sum of u plus b. So therefore, y is equals to u plus b. To determine the derivatives of y with respect to x using increment method derivatives, replace y into y plus increment of y, u into u plus increment of u, and v into v plus increment of b. Transpose the value of y to the right side of the equation and becomes negative. Substitute the value of y which is equals to u plus b and remove the parentheses negative times u is negative u, negative times v is negative b. Then combine similar terms, therefore the increment of y which is equal to the sum of increment of u plus increment of b. Divide the entire equation by increment of x, then establish the limit as increment of x approaches 0 of increment of y all over increment of x, which is equal to the sum of the limit of increment of x approaches 0 of increment of u all over increment of x and increment of b all over increment of x. Or we can write derivatives of y with respect to x is equals to the derivatives of u with respect to x plus the derivatives of b with respect to x. Therefore, the derivatives of the sum of two functions is equal to the sum of their derivatives. For examples, number 1, y is equal to x squared plus 3x plus 5. To determine the derivatives of this given function, derivatives of y with respect to x therefore is equal to the derivatives of x squared, since the coefficient of x squared is 1 and the exponent is 2. Just multiply the coefficient by the exponent. 2 times 1 is equals to 2 and subtract 1 from the exponent. X squared becomes x. So therefore, the derivatives of x squared is equals to 2x. Plus, the derivatives of 3x, which is constant and variable, just factor out 3, multiply by the derivatives of x, which is 1. 3 times 1 is equals to 3. Plus, the derivatives of 5, which is constant, is equal to 0. Therefore, the derivatives of x squared plus 3x plus 5 is equals to 2x plus 3. Number 2, y is equals to 2x minus 5x plus 1. The derivatives of y with respect to x is equals to the derivatives of 2x cubed, since the coefficient is 2 and the exponent is 3. Just multiply the exponent by the coefficient, or 3 times 2 is equal to 6, and subtract 1 from the exponent. X cubed becomes x squared. So therefore, the derivatives of 2x cubed is equal to 6x squared. Minus the derivatives of 5x, which is constant and variable. Just copy the constant, multiply by the derivatives of variable, which is 1. Therefore, the derivatives of 5x is equals to negative 5. Plus the derivatives of 1, which is 0. So therefore, the derivatives of 2x cubed minus 5x plus 1 is equals to 6x squared minus 5. Number 3, derivatives of y, which is equals to 3x raised to the 4th power minus x squared plus 5x. The derivatives of y with respect to x is equals to the derivatives of 3x raised to the 4th power. Since the coefficient is 3 and the exponent is 4, just multiply the coefficient by the exponent, or 3 times 4 is equals to 12. Then subtract 1 from the exponent. X raised to the 4th power becomes x raised to the 3rd power. Therefore, the derivatives of 3x raised to the 4th power is equals to 12x cubed. Minus the derivatives of x squared, the coefficient which is 1 and the exponent is 2. 2 times 1 is negative 2. Then subtract 1 from the exponent, x squared becomes x. Then plus the derivatives of 5x, that is constant and variable, just factor out 5, multiply by the derivatives of x, which is equals to 1, or 5 times 1 is equals to 5. Therefore, the derivatives of 5x is equals to 5. The derivatives, therefore, of 3x raised to the 4th power minus x squared plus 5x is equals to 12x cubed minus 2x plus 5. Number 4. Y is equals to 3 all over x minus 1 all over x squared plus 2 all over x cubed. First, we're going to transform fraction into negative exponent. So we have now the value of y which is equals to 3 times x raised to negative 1 minus 1 all over x squared becomes negative x raised to negative 2 plus 2 times x raised to negative 3. And the derivatives of this, therefore, dy over dx, the derivatives of 3x raised to negative 1. The coefficient is 3, the exponent is negative 1. 3 times negative 1 is equals to negative 3. Then subtract negative 1 from 1, that is becomes negative 2. Therefore, the derivatives of 3x negative 1 is equals to negative 3x raised to negative 2. Then the next, the derivatives of x raised to negative 2. The coefficient which is negative 1 and the exponent is negative 2. Negative 2 times negative 1 is equals to positive 2 and subtract 1 from negative 2 and the exponent now becomes negative 3. So therefore the derivatives of x negative 2 is equals to 2x raised to negative 3. And the last one, we have 2x raised to the negative 3. The coefficient which is 2 and the exponent is 3. 3 times 2 which is equals to negative 6 and subtract 1 from the exponent becomes x raised to negative 4. So therefore the derivatives of 3 all over x minus 1 all over x squared plus 2 all over x cubed is equals to negative 3x negative 2 plus 2x negative 3 minus 6x raised to negative 4. Let's proceed to the derivatives of a product. Considering the same equation y is equals to x. To derive the formula of the derivatives of the product, assume x is equal to the product of u times b. Therefore, y is equals to u times b. And to determine the derivatives of y with respect to x using increment method derivatives, just replace y into y plus increment of y, and u into u plus increment of u, and b into v plus increment of v. And to solve for the value of increment of y, just transpose the value of y to the right side of the equation and becomes negative and substitute the value which is equals to ub. Simplify the equation, therefore increment of y is equals to u times b is ub, u times increment of b is equals to u plus times increment of b, then increment of u times b is equals to v increment of u, then increment of u times increment of b is equals to increment of u times increment of b minus ub. Then combine similar terms. Therefore, the value of increment of y is equals to u increment of b plus b increment of u plus the product of increment of u times increment of b. Divide the entire equation by increment of x, then establish the limit as increment of x approaches 0 of increment of y all over increment of x, which is equal to the sum of the limit as change in x approaches 0 of u times increment of b all over increment of x and b increment of u all over increment of x. Or the derivatives of y with respect to x is equals to u times the derivatives of b with respect to x plus b times derivatives of u with respect to x. Therefore, the derivatives of the product of two functions is equal to the first function times the derivatives of the second plus the second times the derivatives of the first. For example, number 1. If we're going to determine the derivatives of the product 3x plus 5 and 2x minus 3. The derivatives of y with respect to x therefore is equals to, just copy the first function which is 3x plus 5. Multiply by the derivatives of the second function which is 2x minus 3. The derivatives of 2x, since that is constant and variable, just factor out 2 times the derivatives of x which is 1. Therefore, the derivatives of 2x is equal to 2 and the derivatives of 3 which is constant is equal to 0. Therefore, the derivative of 2x minus 3 is equals to 2. Then plus, copy the second function which is 2x minus 3 multiplied by the derivatives of the first function which is 3x plus 5 and the derivatives of 3x plus 5 is equals to 3. Then simplify dy over dx therefore is equals to 2 times 3x is equals to 6x, 5 times 2 is equals to 10, 2x times 3 is equal to 6x, then negative 3 times 3 is negative 9. Combine similar terms, therefore dy over dx is equal to 12x, then plus 1. Number 2. If we're going to determine the derivatives of the product x squared minus 1 and 4x cubed plus 3. So therefore, the derivatives of y with respect to x is equals to, just copy the first function which is x squared minus 1, multiplied by the second derivatives of the second function which is 4x cubed plus 3. And the derivatives of 4x cubed, since the coefficient of x cubed is 4 and the exponent of x is 3, multiply the constant by the coefficient, therefore, or the coefficient times the exponent. So 4 times 3 is equals to 12, then subtract 1 from 3, therefore x cubed becomes x squared, and the derivatives of 4x cubed is equals to 12x squared, and derivatives of x 3 is equal to 0. So therefore the derivatives of 4x cubed plus 3 is equals to 12x squared. Then plus, copy the second function which is 4x cubed plus 3, multiply with the derivatives of x squared minus 1. Since the coefficient of x squared is 1 and the exponent of x is 2, 2 times 1 is equal to 2, then subtract 1 from the exponent, therefore the derivatives of x squared becomes 2x, and the derivatives of negative 1 is equal to 0. Then simplify x squared times 12x squared is equals to 12x raised to the fourth power negative 1 times 12x squared is negative 12x squared plus 4x cubed times 2x is equal to 8x raised to the fourth power, then 3 times 2x is equal to 6x. Then combine similar terms, therefore the derivatives is equals to 20x raised to the fourth power plus or minus 12x squared, then plus 6x. The last one, which is the derivatives of a quotient. Considering the same equation y is equals to x, just assume x is equals to the quotient of u all over b. Therefore, y is equals to u all over b, and determine the derivatives of y with respect to x using increment method derivatives. Just replace y into y plus increment of y, as well as the value of u into u plus increment of u and b into v plus increment of v. Then transpose y to the right side of the equation in order to solve for the value of increment of y, and substitute the value of y which is equals to u all over b. Then find the LCD or simplify the given fraction, so we have this resulting equation. Then expand the given equation. Then you have now to combine the numerator. The resulting equation of increment of y is equal to b increment of u minus u increment of v all over v times the quantity v plus increment of b. Then next, divide the entire equation by increment of x. Then simplify and establish the limit as change in x approaches 0. So therefore, the limit as change in x approaches 0 of increment of y over increment of x is equals to b times the derivatives of u with respect to x minus u times the derivatives of v with respect to x all over b times b plus 0. Or we can write this one into derivatives of y with respect to x is equals to b times derivatives of u minus u times derivatives of b with respect to x all over a square of b. So therefore, the derivatives of a quotient is equal to the denominator times the derivatives of the numerator minus the numerator times the derivatives of the denominator all over the square of its denominator. For example, number 1. y is equals to 3 all over 2x. And the derivatives of y with respect to x, just copy the denominator, multiply by the derivatives of the numerator, which is 3, and the derivatives of 3 is equal to 0. Minus copy the numerator 3, multiply by the derivatives of 2x, which is equals to 2 all over the square of the denominator. Therefore, the derivatives of y with respect to x is equal to negative 6 all over 4x squared. Or we can still simplify this one, which is equal to negative 3 all over 2x squared. Number 2, y is equal to 5 all over 3x minus 4. So we have the same procedure. The derivatives of y with respect to x, just copy the denominator, which is 3x minus 4, multiplied by the derivatives of the numerator, which is constant. So therefore, the derivatives of 5 is equal to 0. Minus, copy the numerator, which is 5, multiplied by the derivatives of the denominator. Since the denominator is 3x minus 4, the derivatives of 3x is 3 and the derivatives of 4 is 0. So therefore, the derivatives of the denominator is equals to 3 all over the square of the denominator 3x minus 4 squared. So therefore, the derivatives of y with respect to x is equals to negative 15 all over 3x minus 4 squared. Number 3, 2x all over 5x minus 1. The derivatives of y with respect to x, just copy the denominator, which is 5x minus 1, multiply by the derivatives of the numerator, which is 2x, and the derivatives of 2x is 2. Minus, copy the numerator, which is 2x, multiplied by the derivatives of the denominator, which is 5x minus 1. The derivatives of 5x is 5, and the derivatives of 1 is 0. Therefore, the derivatives of the denominator is equals to 5 all over the square of the denominator. Then, combine similar terms, which is equals to the derivatives of y with respect to x is equal to negative 2 all over 5x minus 1 squared. Number 4, y is equal to 3x minus 2 all over 2x plus 1. And the derivatives of y with respect to x, just copy the denominator, which is 2x plus 1, multiplied by the derivatives of the numerator, which is 3x minus 2, and the derivatives of 3x minus 2 is 3. Minus, copy the numerator 3x minus 2, multiplied by the derivatives of the denominator 2x plus 1. The derivatives of 2x is 2 and the derivatives of 1 is 0. Therefore, the derivatives of the denominator, which is equals to 2, all over the square of the denominator. Then expand the numerator. 2x times 3 is equals to 6x. 1 times 3 is equals to 3. Negative times 3 times 2 is negative 6x. Negative times negative 2 times 2 is equals to positive 4. Then combine the numerator. Therefore, the derivatives of y with respect to x is equals to 7 all over 2x plus 1 squared. Then number 5, y is equal to 3x squared minus 1 all over 4x cubed plus 3. So we have the same procedure for the derivatives of y with respect to x. Just copy the denominator, which is 4x cubed plus 3. And the derivatives of the numerator are 3x squared minus 1. The derivatives of 3x squared, just multiply 2 by 3, that is becomes 6, subtract 1 from the exponent, and that is now becomes 6x, and the derivatives of negative 1 is 0. So therefore, multiply by the derivatives of the numerator, which is equals to 6x. Copy the numerator 3x squared minus 1, multiplied by the derivatives of the denominator, or 4x cubed plus 3. The derivatives of 4x cubed, 4 times 3 is equals to 12, then subtract 1 from the exponent, that is becomes 12x squared, and the derivatives of 3 is 0. So therefore, the derivatives of the denominator becomes 12x squared, divided by the square of the denominator. Then expand the numerator, or 4x cubed times 6x becomes 24x raised to the 4th power. 3 times 6x is equals to 18x minus 3x squared times 12x squared is negative 36x raised to the 4th power. Negative 1 times negative times 12x squared becomes positive 12x squared. then combine the numerator. Therefore, the derivatives of y with respect to x, negative 36x raised to the fourth power plus 24x raised to the fourth power becomes negative 12x raised to the fourth power. Then just copy 12x squared as well as 18x all over the square of the denominator.